Hello students, this is lecture 17 and we are into chapter number 4. Okay, so some contents are also in chapter number 5, so chapter 3, 4, 5 are such thing that they go hand in hand. Hence you will see like we have things from chapter 3 also, from 4 also, a little bit from chapter 5 as well. Okay, but we try to go as per the textbook as much as I can. Okay, so we have seen the advantage of writing the interpolation function, like writing the test function as a combination of interpolation function, meaning that if we write something like u as ux, we divide it into u1x, u2x, and so on. So for different domain, yeah, so we have total L from here to here, and we have within that we have some elements, yeah, so length here is L1, this is L2, this is L3, and within each of them we have one of them defined. So this defined here, this defined here, and so on, right? Okay, so we can, instead of looking at the global point of view, means looking at u as we did the last time, we can also see it from the perspective of the element itself. So let's say we are looking at the eth element. Okay, and in that case what happens, this is eth element, and we have here u e1, this is u e2 are the two displacements, yeah. So and we have the axis system of xe, and hence we can write u within this element as a function of xe will be equal to, we can write like this, summation of I equal to 1 to 2, and then we have n, this one is n 1 ni, right? We have e ni, and then we have u u I, right, which is a function of xe. Yeah, so what we did, this means ue will be equal to n1 multiplied by u1 plus n2 u2, where this one is a function of, so n I e is a function of xe are called the shape function. Shape functions, there are two of them. So the value, if you, we have seen the last time in last lecture video, this if you have n1 is it goes like this one, the value is like this. So this is 1 here, this is 0 here, okay, this is 0 here, this is L1, okay. So basically we can write NE1 also, LE goes like this one, and this is what the NE2 will look like, okay. So this will have 0 here and 1 here, okay. So this is 1 here, yeah, this is what the expression is, yeah. So if you look at the expression, we can also write NE1 as a function of x E is equal to 1 minus xe over Le, okay, and n E2 xe is equal to xe over Le. You can see from both that summation of n ei is equal to 1, right. So, if you add them together, this plus this, see this here minus, here plus, cancel out, you have only 1, right. So, this like that, okay. So, anyway, so looking at from the element point of view, so the way we were writing here, same thing we can you can draw. So, we have here u e1 u e2, and accordingly there will be the force or a stress as well, right. The stress here, let us say this is a stress sigma 1, or we can this one is EA d u over dxe, right, okay, at x equal to Le, right. So, E times A, this gives you a force basically, right. This is the force, yeah. So, we can write this one is F because of element 1, F2 is like this, yeah. Similarly, here there will be this force as well, or we call it F E1, yeah, will be equal to EA, then du E dxe, right, at xe equal to 0, right. So, this is how it is defined, right. So, we have this given this like this one, and for this this is for element number E, yeah, okay. If that is the case, we can apply the even the weak formulation. A weak formulation is for this one, just for this one we can apply the weak formulation, and this becomes 0 to Le, right, and then d w E over dx, E is a function of x e, here also a function of x e possible, and du E over dxe we can write, and dxe is equal to, yeah, is equal to this may have also other things as well. For so for example, this will be equal to, and then it will be 0 to Le again, you will have b x e, then it will have w e x e dxe, yeah. Also, since it has the forces also we do not know, like we are talking about a big problem here, and just we are talking about this one, which is the element number E, yeah. So, they do not have any boundary if you see here, yeah. But let us say we are just analyzing from this point of view, there will be a bond to this one, yeah. So, where there is a interaction with F basically from this side and that side, okay. So, that means there is a B, there is a this one body force as well, B is given like this, okay. So, now if we expand the values what we used earlier as u like this one, similarly we can also have in the same fashion, the way we are using this one, we can also write W basically. So we can say WE XE is a summation of I equal to 1 to 2 N I E W I E X E. We can also write exactly the same way, same manner. This we can write. Okay. So if that is the case, then this equation, this equation we can get if you put those values, these values and this, if you put these values, this whole equation becomes you can actually work out yourself, and you will find this will be W E this will be W E 1 W E 2, and then you will have K E 11 K E 12 K E 21 K E 22, right? And then you will have here U E1 U E2 is equal to, you will have some kind of here F. Okay, so you will have here F some value of like this. So we can write in two terms. You will have F of E also, and we can write this will be B1, this will be B2. Okay, so which is coming from the body force, yeah, and there may be also the concentrated forces also can be there. Yeah, so if the element itself has some concentrated force at the ends, yeah, so either there is a concentrated force, if you are looking at the element, either it will have some force, some reaction forces. If you cut it here, for example, there will be some force which normal force here. So this is the normal force we are talking about. So at the end, whatever the normal force is, that will be there. So this is because of the internal force, right? This is because of the internal force that will be there, and these are the forces which are because of the body forces. Yeah. So all combination. Yeah. So you can look this as independent, which has this external force applied, also this internal force applied, and hence this is an equilibrium. So if you are studying this alone, we have to care about all of them, so we have to write accordingly, right? So we can write this which is coming from the body force, plus we have write Fe1 and Fe2, and what is the meaning of Fe1 Fe2? Basically we have to also look at the sign also. So remember here this is the negative side, we call this positive, so we have to say here minus. This has to be minus sign, this will be a plus sign. So accordingly we put value, this the first one will be minus sign, second one will be plus sign. So we use this one as minus sign like this. Okay, so this is minus, so and this is plus, okay. Why minus? As I said here, like the forces here and here, if you look at it, here it is this way, here it is the back side one, back like this one. So the stress is positive, but the force is negative because this is negative x direction, and hence we have to write it as minus. In contrast to this b, if you see, this is positive. Yeah, so this is positive x direction. This is positive x direction, hence positive, and this is negative x direction, hence negative. Second perspective, why you will get negative also come from the weak formulation. You remember the weak formulation, it has, if you see the complete picture, it tells you like this: 0 to L du over dx Ea dw over dx dx, right. We had this term, and then we had like this minus this, then we had plus, plus we have w Ea du over dx, and then you have L and 0, right, and then you have plus 0 to L and w b dx all equal to 0. So, if you see here, L will come here, then this one we know that Ea, so expand this one, right. So, look at this one. So, what it will be? W L Ea du dx at x equal to L minus W 0 and Ea du over dx at x equal to 0. So, what you will see, both will have opposite sign. Here it is positive, here it is negative. Hence, automatically one will be negative, one will be positive. Which one is negative? Well, negative, you have to look at with respect to this one, right. So, with respect to this other force. This force, if E positive here, so the one at L is positive, the one at 0 is negative, and hence you have one at L will positive, means F, this one Fe2 will be positive because it is at L, and f equal to 0 is Fe1 will be negative. Both has opposite sign, hence you get the opposite sign here, hence this will be negative. So, this also comes from there, just to explain. Okay. So, basically the idea is you will from the weak formulation also for the that element only. Okay, we are not talking about the whole thing, the just element also you will get this equation where so where k e I j will be equal to 0 to L e, length of the element, and then you have n d n e I d x e, then e as a function of x e, a as a function of x e times d n e, here it will be j, jth one dx e dx e. So, this is what that will be. This we know, this we have to find, right. So, here Fe1 and all those things, this is, so basically this F E B1 will be equal to 0 to L E, then N E B1 you can write as I, ith one. So, I, and then we have W, not W, W is gone. So, B as a function of x e, this is also a function of x e only, and then we have dx e. Okay. So, this is what the FBI is, right. So, 1, 2 you can find out based on this one, and F E I is equal to 0, not 0, but this is simply E right, E A d u e over dx e at x equal to this one, if it is 1, this is if 1, we are talking about at x equal to 0, and if it is as Fe2 equal to Ea due dxe at x equal to Le. That is what that is. Yeah. So, this gives you complete picture. So, what from the element point of view also, what you see is no, okay, one thing I forgot. Actually, if you have this value here coming, the same thing you will come, you will be coming. So, we can have everything in under brackets. So, the everything like bracket like here, whole thing. Yeah. So, this will be W1, W2 will be common to both of them, because this will also appear on the right side. Why? Because on the right side also we have W term here. Yeah, we have W term here, and hence this also be on the right side. Here also we have W this side also. So, W1, W2 will be common, and since W1, W2 are arbitrary, we will get rid of them, and what you have is basically only this multiplied by this equal to this we will get rid of. Yeah, and this is true for the every element, and hence you assemble the same way you assembled in the chapter 1, same way you will do it, where we have these values are exactly are like this one. Chapter 5 will deal all those things, you know. So, we are little ahead in the chapter 4, we are talking about this one, because we want to make sense what we are doing is correct or not, you know. So, we will do in details in chapter 4, you know, we will solve the problem. Chapter 5 we solve the problem. Right now what we want to do is just to get a motivation, what is the idea behind using the shape function and what is the end, right. So, what is why we are writing those way and what is the meaning of physical meaning of doing of this. That is one thing. Second thing, time and again we see there is a integration. Yeah. So, numerical integration is important. So, today in this lecture we will also have the numerical integration as well. Okay. So within the element we are basically we want to write as uex equal to ne1 x u e1 plus ne2 multiplied by u e2. These two are shape functions, and as I said this is linear, and how they vary, you have n1 vary from here to here and n2 you are vary here to here. So, this is n1, this is n2, this is 0, this x e equal to L e. Yeah. Okay. And this is a linear system. This is true that this makes it linear, meaning that the combined effect is such that it goes like this. This is a combined effect. Here you have u1e, here you have u(e2). Now, the question is, suppose you want to have a interpolation function not linear but quadratic, right. So, if uex is quadratic, then what? And why you want to make quadratic? Because it improves your accuracy basically. As you know, the actual solution in the example problem we have been working on is quadratic, and hence if we take the trial function as quadratic one, it will exactly solve the problem. So, why not? but in that case how will we do? How can you write it? Okay. Can we write the same way, the way it is written? Here what we have, this is a linear function multiplied by a constant, is a nodal displacement, plus linear function into coordinate, the displacement. Now can we write the same way, something like a quadratic equation multiplied by displacement plus quadratic equation multiplied by displacement? Can we do like that? Well, you can do it, only thing is we do not know how they are varying. Okay. So if you see, if we had to do the original way, we would write something like this: ux equal to alpha naught plus alpha 1x plus alpha 2x square. So we have 3 unknowns. Only thing is, in this case if you write like this, n1 and n2, then if you have to make this quadratic and this quadratic, n1 and n2 will be quadratic multiplied by 2, like this one. But it will not give you much freedom. It may not, probably it is possible that it may not fit, because you do not know the value of this. Why you do not know? Or you can your results will not be correct, because in order to express quadratic equation you need 3 there are 3 unknowns with 3 constants basically, right. So alpha naught, alpha 1, alpha 2. So in order to fit this u, you need 3 parameters to fit. Here you have only 2 parameters, only this and this. These are those constants, and here these are the functions which you may change into quadratic. So how is it possible that you have just 2 unknowns and then you can fit any quadratic function? It is not possible, right. So hence you need 3 you need 3 parameters to exactly fit any quadratic equation, any quadratic solution, right. Hence basically you can say that we need 3 displacements basically. So you need 3 constants or displacements. So instead of having displacement values at 2 places, if you have at 3 places you can do it. So something like this, if you let, this is a one element only, but it has 3 nodes. Let's call 1, 2 and 3. Then now you can write, now you can write uex equal to a summation of n e I x e, and then you have u e I, and then you will have I equal to 1, 2, 3, where n e I is quadratic shape function. Now you can do, because now you have 3 displacements or 3 parameters now inside the u, and hence now it can fit any quadratic solution now. So this is u e1, u e2, and this is u e3. So this should now work. Only thing is we have to find out how will this look like. If we had only 2, n1 looked like 1 here, 0 here, linearly changing to 0, n2 look like 0 varying to 1. How does this look like now? Then we have to work out. How to work out? Work out like this. We know that if u e x e equal to 0, right. So we have this point is this point x e equal to 0, this point x e equal to L e, and this point x e equal to, we can say L e over 2, let us say, right. So, exactly in the middle, so it will be L e over 2. Hence, we can use 3 equations we can make from here. We can accordingly find out what is the value of that, or value of what. We can have like this. So, u e at x e equal to 0 is equal to, you know that this has to be u1 e. Similarly, u e, what does it tell you? It tell you that if you put this value here, x e equal to 0 put here, so 0 here, then what happens? That tells you that n1 e at 0 is equal to 1, n e to 0 equal to 0, well, is n e 3 equal to 0. That is what I tell you at 0, sorry, at x equal to 0, as 0 has to be 0. Why? Because u e is given by n1 multiplied by u1 plus, right, this is what it is, right. So, this is equal to n1 u1 plus n2 u2 plus n3 u3, and if u equal to u1 only at x equal to 0, so only possible when n1 is 1 and n2 is 0, n3 is 0. So, these terms all go 0, this becomes equal to 1, hence this will be equal to u1 only. So, that is why, right. Similarly, you will have expression for others like u e x e equal to L e equal to u e 3, that really means n not 3 but 2, sorry, 2, right. So, this is 2. So, this means simply that n e 1 at x equal to L e has to equal to 0, right. Similarly, n e 2 at x equal to L e has to equal to 1, and n e 3 at L e has to equal to 0. So, that since we are, what we are doing? We are doing u or test function as shape function n1 multiplied by displacement, n2 multiplied by displacement here, n3 multiplied by displacement here. Hence, if u is equal to u to okay, just a minute. Okay, guys, here we are writing, we should have written e here and 3 here. Similarly, this is e, this will be 2 here. Okay. Okay. So, this is how these are the conditions basically that we have to fulfill, and we will get that. Yeah. So, basically the we can assume, for example, n e 1 is equal to say alpha 1 plus beta 1 x plus xe basically plus alpha beta gamma 1 xe square. Okay. So, we can have like this, and we have to find out value of alpha 1, beta 1 and gamma 1. In fact, for we have 3 shape functions now. So, we can have simply equal to alpha I plus beta I xe plus gamma I xe square, and we can find alpha I, beta I, gamma I such that which all things are there. We have n I e, so n e I at, so we have like this one, yeah, 3 nodes, node 1, 2, 3. Okay, so x e equal to 0 here, x e equal to L e here, and x e equal to L e over 2 here. Okay, so this is the form of the quadratic equation we are expecting for the shape functions, and we have to find out this coefficient by imposing this kind of condition, yeah, imposing these conditions, right. So, n e1 0 equal to 1, otherwise they are 0. So, they are equal to 1 correspond at one of the points, the other points they are non-zero, right. So, so basically n I e at we can write it like this one. Let us say this is when we are, this we may refer to x e1, this we may refer to x e2, this we may refer to x e3, right. So, if we say x e1, that really means nodal coordinate of node 1, of node 2, nodal coordinate of node 3. So, this tells you simply that we can write in easy way that if it is at x e j will be equal to 1 if I equal to j, equal to 0 if I not equal to j. Yeah. So, n I, like for n1 will be 1 at x1 and will be equal to 0 at x2 and x3, right. So, this is what you have to impose the condition, and by doing that we can find out alpha 1, alpha 2, alpha 3. Okay. And how will it look like? Okay. So, basically we can, let us say we are going to plot n1, n2, n3. So, say this is 1, 2, 3, and how will it look like? This will look like something like this. 1 has to be, n1 has to be 1 at node 1, has to be 0 at node 3, and has to be 0 at node 2 as well. So, hence it will go like this one. So, this is n1. n2 similarly, it has to be 1 at node 2, then 0 at node 3, and 0 again at node 1. So, it will go like this one, and n3, this is n2, n3 has to be 1 at node 1 and 0 at n3 has to 1 at node 3 0 at node 1, hence it will go like this, and again it will be 0 at node 2, hence it will go like this. So, this is how the function will look like if you work out, if you solve them. If you solve them, this is how it will work out. So, basically the details we will do later on, we are looking at the big picture. Okay, so how to find out what is the meaning of that, and this way whatever you get once you get n1, n2, n3, means once you get alpha I, beta I, gamma I, there are 3 of them, right. So, 3 equations. So, you will have I equal to 1, 2, 3 basically. So, 3 times 3, 9 unknowns, we have 9 equations as well, and then you can exactly find out those functions. You can plot, the plot will look like something like this. And once you have these functions, quadratic function, you can find out the test function, right. And your functions, then as we have written earlier, uxc will be summation of NEIXE multiplied by UEI, right, and this will be I equal to 1, 2, 3 in your case, because this is a quadratic, yeah, where NE itself is a quadratic function, yeah, like this one, and hence it is going to interpolate. Okay. So, pictorially this will like this one. Okay. So, basically if linear, your n1 is goes like this one, or we can write in briefly, you can write u equal to n1 u1 plus n2 u2, and where n1 is like this, n2 is like this one. Always n1 plus n2 will be equal to 1, and n1 will move from here to here, and you have u1 here, this is u2 here. You have quadratic here, you have 3 point u1, u2, and you have u3, and your variation here goes like this, and goes like this, and goes like this, and you have in this case u equal to n1 u1 plus n2 u2 plus n3 u3. Here also n1 plus n2 plus n3 will be equal to 1 only. However, n here is a line, as you see here n is a quadratic function, as you can see that, but all of them also get to that. Okay. So, similarly other kinds, if you take 4, let us say if you want to make a cubic interpolation function, then you know that you need 4 nodes then, right. So, you will need 4 nodes. So, you will say u1, u2, u3, u4, and how the curve will change? Well, you can guess now. The n1 will start will be 1 here, has to be go to 0, then 0 again, then 0, like this. This is n1. Okay. Now, n2 has to be 1 here, and it has to be 0 at other places. So, it will go like this, like this, like this. Yeah. So, this is n2. Okay. Now, n3 will be again 1 here and 0 at other places. Yeah. So, it will go like this, yeah, and like this. Okay. So, this is n3. n4 will be 1 here and 0 at other places. So, will go like this, like this, like this. So, this is n4, roughly drawing, but you know that how it will look like. So, only n4 will be 1 at node 4 and all other place it will be 0. Yeah. So, simply what it means is Ni will be 1 at node I, Ni will be 0 at all other nodes, simply as simple as that. Yeah. So, this is the idea. Okay. Accordingly, you can like compose any kinds of interpolation function or any kind of test function basically. So, the summary is, if you want a cubic test function, then you will need 4 nodes per element. So, this is only one element which has 2 node, only one element which has 3 node, this is only one element which has 4 node. You will call this 2 noded element. Yeah, so, this is 2 noded element, this is 3 noded element, this is 4 noded element, and this is the deal. Now that we know the meaning of linear, quadratic or cubic element, linear, all these are for the 1D problems only. We know how n1, n2, in this case n1, n2, n3 or n1, n2, n3, n4 should look like. What is the condition they have to fulfill? Based on that, actually we can compose these shape functions n1, n2, n3, n4 and so on. We can, for example, let us say we want to, for linear function we want to find out, let us say for linear shape function we have to find out the expression, right. So, let us say the length L is equal to 5, yeah, and then you know that this will be 0, this will be 5. Now, how to find out n1? n1 will be equal to, so n1 has to pass through which one? We have to pass through this, right. This has to pass through. So, if you see the equation of line, if you look at this, n1 has to go like this one. So, x equal to 5, x equal to 5 is the root basically, right. So, if xe is like the x equal to 5 will be the root. So, we can write this has to be a function of, let us say, call it alpha times xe minus 5, right. Okay. It should be like this one. Yeah. Similarly, n2, if you see n2 will be 1 here, 0 here. So, this is n2, and we know that n2 has to pass through x equal to 0. Hence, this will be n2 will be something like, let us say, beta times xe simply, right, xe. We know that, right. So, just looking at the through which point it has to pass, we can guess how in the shape function build should look like. From here, we can also see that n1 has to be 1 at 0, right. So, what you see is n1 is equal to alpha times 0 minus 5 or minus 5 alpha equal to 1, and hence it tells you alpha equal to minus 1 over 5, and hence this tells you that n1 will be minus 1 over 5 xe minus 5, which is equal to basically 1 over 5 xe 5 minus, or simply we should write, is equal to 1 minus xe over 5. This is what we will, this is the answer, right. Similarly for this one, this of this form, because this is going to pass through x equal to 0, hence it will be this form. However, this also satisfied, this has to be 1 at x equal to 5, right. So we have to write n2 equal to 1 equal to b, and where x equal to 5 times 5, and hence you know that beta equal to 1 over 5, and hence n2 equal to 1 over 5 xe, where 5 is basically L only, right. So basically xe over Le, yeah, and this is equal to 1 minus xe over Le only, right. So this is how we have we got this exactly same thing different way. Yeah, so here we are getting this way. Now this makes our life simple. So if you want, for example, quadratic, and then we have 3. So now you can choose your way, even if it is Le, let us say Le is given, right. So Le is given. So you can choose such a way it is convenient to you. So you can say, instead of x starting here, since this is local, instead of x starting here, you can say our x starts here, and that way it will be minus Le over 2, this is plus Le over 2, and this is 0, and this is how x is moving. So this is very convenient this way. Yeah, why? Now we can write n1, right. So n1 is goes like this. Yeah, so this is we call it 1, this 2, this is 3, go like this. Okay, so n1 is will be equal to n1 exe will be equal to, now n1 this is n1, and if you see, it passes through x equal to 0, passes through x equal to Le over 2, hence these are the two roots. So we can write, we know the factor now, so this will be equal to, let us say, alpha multiplied by xe minus 0, this is the first root, multiplied by xe minus Le over 2, and this is the second root, right. This, yeah, this is how it should look like, right. And you see that already it has x here, so it becomes a quadratic already, so no other term will be there. Yeah, it has two roots, one root here, one root here. Only thing we have to know alpha, and how alpha we will find out if we put x equal to minus Le over 2. So this tells you n1e L minus Le over 2 is equal to 1 is equal to alpha, and put those values here. So minus Le over 2, so we get minus Le over 2. Okay, fine. And then here xe minus Le over 2, minus Le over 2, so it becomes Le basically simply. So it becomes minus Le, and this will give you alpha equal to minus plus Le square over 2, so alpha equal to 2 over Le square. Okay, so basically you get the expression for n1. So n1e xe will be equal to 2 over Le square, and then you have xe times xe minus Le over 2. So this is the first shape function. See, exactly we found it, so exactly we got it. Okay, similarly we can get the second one. We will play the same trick. So L2. Okay, so we have L2 like this one. Yeah, and how do we have? We have 1, 2, and here we have 3. Okay, so we are looking for the second one. We know that it will come like this one. So the values are here, this is xe equal to 0, this xe equal to minus le over 2, and xe equal to le over 2, that we know, right? All the 3 points. Okay, so you know this is n2 basically. So yeah, so okay, so n2e will be equal to some function beta multiplied by, then it has the first root here. Okay, so will be x minus of minus le over 2, so x plus, so the first factor will be x e plus le over 2, and second factor will be this one. Yeah, second factor is xe, so we write just xe only, that's it. Yeah, so that we have, if you put this equal to 0, we will get x equal to 0, which is this point where this value is 0, the n2 0. Second will be this one, so xe will be equal to minus le over 2, and so this is the point. Okay, so this is how n2 will look like. Now again we have to see n2 has to be 1 here, right? So ne2 equal to 1 at where? At xe equal to le over 2 has to be equal to 1, and which is equal to beta, and then we have le over 2, and then we have the le only. So here we have le over 2 and xe also le over 2, so we have le multiplied by this is le over 2, so we have le over 2, and hence that tells you beta is equal to 2 over le square, and hence you get ne is equal to 2 over le square, and then xe plus le over 2 and xe. Okay, so we found out. Similarly, you can find out third one. Third one, what do you see? Third one goes like this. Third one is like this. Yeah. So 0 first and second, this is n3. So we can write n3e is equal to let's say it's a gamma, and we will have first one is at xe equal to le plus 2. So first factor will be xe plus le over 2. Yeah, okay, this is the first factor. Second one is xe minus le over 2. Yeah, so two of them, this is 0 here, 0 here, so that if you make this equal to 0, we will get xe equal to minus le over 2, so which is this one, or x equal to le over 2. So this is, these 2 points will be the root, and hence you get that. Now we have to find out gamma such a way that n3 will be equal to 1, and hence we can find out like that. So we can do that. So ne3 at xe equal to 0 is, has to be equal to 1, which is equal to, so we have gamma and then x like 0 square minus le square over 4, right. So we have xe plus here, xe minus here, the same thing. So we have xe square minus le by 2 square. So xe equal to 0, so you have le square 0 minus le square over 4, right, and this will give you which is equal to minus gamma le square over 4, and hence gamma will be give you minus 4 minus 4 over le square. Yeah, and hence hence you get NE3 XE will be equal to gamma is 1 over 4 LE square, and then you have X E XE minus LE over 2 multiplied by XE plus LE over 2. So, this is what you get the 3 1. So, thus you got the thing, this shape function or the interpolation function, and inside that element now x will be given by a summation of n I E x e times u e I equal to 1 to 3. So, this is what the interpolation function will work at. Yeah, so that means if you plot this one, it will look like something like this. So, you will have something like this. Let us say at one point is this one, the u and like this. Yeah. So, let us say this is the u e1 u e3 u e3 and this is u e2. So, the curve will go like this and be like this. Yeah. So, this how this will capture the curvature, basically what I mean. Yeah. So, now since these are quadratic functions, automatically it will be a smooth curve which will be going from here to here. Yeah. Okay. So, this is what the shape function is, and so given this value, so we can solve one small example like based on this only. So, let us say given is one problem in which you have an element like this one. It could be a temperature, right? So, it could be, let us say temperature T1 equal to 5 degrees Celsius, yeah, and temperature T2 is say 100 degree Celsius, yeah, okay, and this T3 is equal to say 10 degrees Celsius. Yeah. Okay. If it is like this one, then you have to find out Tx. Let us say this is x is varying, this is x is varying like this one. So, this is x equal to 0, let us say x equal to 10 meter, x equal to 1, let us call x equal to 1 here, yeah, and this one is x equal to half. Let us say it is like this one. Then we have to find out t as a function of x equal to 1, right. So, how to do? So, following the example, we can it will have n1 t1 plus n2 t2 plus n3 plus n3 times t3. That's what it will be. Okay. Okay, and where n1, n2, n3, all those things we can put together. So, where we have n1, where n1 as we have seen n1 is equal to so this is n1, right, 2 over LE. So, LE here is 1, right. So, LE element length is 1. So, 2 over 1 square, and then you have XE. So, you have XE minus half, right. So, this is what it is. So, 2 times x minus half, two times x minus half. So, this is what it is, right. So, basically x 2 2 times, okay, let it be like this only. So you got this, okay. So and n2 will be similarly, so plus 2 will be there, so or we can check it out, okay. So n2 is here, so 2 over 1, and then we have x plus half x. So only thing there is we have plus sign here. So okay, there is a problem here. I think it had to be minus here, otherwise if you put x equal to minus 1, no, it's fine, so it will be minus 2. Okay, so yeah, so n2, let's see n2 again. So n2 was this one, so 2x plus half x, 2, so 2x x plus half, and n3 is equal to minus 4, LE is 1, so minus 4, and x minus half, x plus half, so x square minus 1/4. But this is minus value, here is a plus value, and here plus value, okay. So last one is minus 4, so accordingly we can write minus 4, then x square minus 1/4. So that means Tx, we can, this is how we can write Tx will be equal to T1, so n1 times T1, so we write 2x x minus half T1 plus 2x x plus half T2, then minus 4 x square minus 1/4, then T3. So this is what T will look like. Accordingly, if you want to find out what is the value of T equal to say 3/4, T equal to 3/4, or T equal to 1/3 or 1/4, you can find out the value, what will be the value here. Yeah, so but this is the formula now. Yeah, okay. So let us say we are just to continue on this example, if you find out T x equal to 1/4 equal to what? Yeah, equal to what? If I want to find out, so then what we will do, we will put this equal to, and we put x equal to 1/4 in all of them, right? So we have 2 times 1/4, so you get half here, and 1/4 here also, minus 1/4, right? So 2 times 1/4 multiplied by 1/4 minus half, okay, 1/4 minus half, and T1 equal to 5, so let's write 5 multiplied by 5, right, okay, then plus 2 1/4 plus half, so 2 1/4, 2 times 1/4 multiplied by 1/4 plus half, right, multiplied by T2. Yeah, so T2, and T2, let's assume it is 100 degree Celsius, no, it is given 100 degrees Celsius, so we write multiplied by 100, say 100, and then minus 4 and then 1/4 whole square minus 1/4, and then T3 is 10. Okay, so minus 4 1/4 square minus 4, so 1/16 minus 1/4 and into 10. Yeah. Okay. So this is the what the value of t will be at x equal to 1/4, right? So it will be equal to half multiplied by minus 1/4 multiplied by 5 plus half into 3/4 multiplied by 100 minus then we have 4 multiplied by minus 3/16 into 10, which is equal to, here we have 5 divided by minus 5 over 8 plus 300 divided by 8, right, minus plus, so 12/16. Okay, so we have 12/16, so write 6/8, 60/8 rather. So we have 10 times 4 times 3, so 120 by 16, so 60/8, right, and that will be equal to 8, and then we have minus 5 plus 300 plus 60, it will be 365/8. Yeah. So basically t at x equal to 1/4 equal to, it will be, so 8, so 4, so we have made some mistake actually, sorry about that. So what we see is minus here, so it will not be 365, rather it will be 355. Okay, so I will do that correction. So this will be 355 divided by 8. Okay, so the value will be equal to, so 355 divided by 8, so we get 8, we will have 4, first 4, so 32, so minus 32 will be 35, so okay, so we have 8, so let's quickly work here. So 8 32 gone, so that's what 4 is, so 35, so then we have 4 again, right, so we will have 4 again, okay, and then we have 3, so we will have point some value, yeah, so 30, the 0.3 something, right, so degree Celsius. Okay, so the value we are getting is 44.3, right, so value, okay, so first of all we have to be careful, because our derivations are based on x equal to minus half to plus half, right, it is like this one. So whenever we said x equal to, if I want to find out we put x equal to 1 over 4. So that really means what it measured is here, not here basically. Yeah. So basically the idea was not to have x equal to 0 here, x equal to 1 here, but x equal to minus half here, yeah, and x equal to plus half here, and x equal to 0 here. Yeah. Okay. So we have to formulate accordingly. If it is given, then we have to like convert basically into the standard format. Yeah. So since this is 3 noded element, we derived n1, n2, n3 with the origin here. Hence, when we have to interpolate accordingly, we also have to place the origin in the middle only. Then only it will match. Otherwise, it will be problem. Yeah. So length is L, x equal to minus half here, x equal to plus half here, here x equal to 0, and we want to find, we wanted to know what is the temperature at x equal to 1/4. Yeah, and accordingly we put those values, and we found the value to be 44.3 around, which makes sense because if you see x equal to minus half, you have 5 degree, x equal to 0, you have 10 degree, and x equal to 100, you have 100, x equal to half, you have 100 degree. Hence, the value has to be between 10 and 100, and we get 44 around. So this makes sense. Yeah. So this is how you have to do and how you have to be careful, you know, so when interpolating. Okay, that is all for this video.